All right, also test 4 review. All right, so 25 questions on this, okay? So number 1 wants me to graph y equals 1/3 to the x. Now remember, since this is a fraction to an exponent, we know this graph is going to sort of come down from the left and fall as it goes to the right, okay? So we're going to go in and graph this on our calculator and see what we get. I'm going to go to y equals. I'm going to put my fraction in parentheses, 1 divided by 3, close parentheses, and then my exponent was my variable, the x. All right, y'all, I'm just going to hit graph and see what it looks like. There you go, falling down from the left. So I would pick the picture. It's going to have 4 pictures. Pick the one that looks like our graph, okay? I'm just going to sort of sketch that real quick. All right. I also, like I said, we picked a picture that had that graph coming down. It does not cross the x, remember, it just gets closer and closer. All right, number 2 wants us to describe the graph. So they're giving us f of x equals 2 to the x plus 4. All right, so on this part, we tell it what we start with. So we start with the graph of y equals blank to the x. Now, they've already got the x there. So all they want you to do is put the base here, and our base is the 2. So we will put our 2 in. Then we got to tell it, what is this 4 doing to my graph? So remember, when the 4 is up here with the exponent, it's moving me left or right. So this graph is going to go left 4 units since that 4 is positive, okay? If that had been a -4, then it would have moved me right. So we start with the graph of y equals 2 to the x, and then we shift the graph 4 units to the left. Okay, so you got to pick the option that has 4 units to the left and put in your base of 2. So the 4 options will be left, right, up, or down, okay? Now to graph this, when you open up the graphing, you're going to choose the exponential tool and click anywhere on the graph. Once I click on the graph, it's going to open up the controls. So since mine went left 4 units, I would move the horizontal shift to -4. Now, the most important thing, remember to change the base in bottom left corner. So remember, that little box opens, you move your control for your horizontal move. In the bottom, it'll say base. Remember, where it says base, by default, it's got the little E there. You got to actually tell it that your graph has a base of 2, okay? Once you do that, it's going to move the graph and be done. And let's see, number 3 is doing the same thing. So we're going to describe the graph. So 2 of those in a row. This one has f of x equals 2 to the x plus 5 minus 3. So this one's got 2 moves on it. So let's see, we start with the graph. Y equals blank to the x. And let's see, once again, my base is a 2, so I would put a 2 in the box. Then it says shift it blank 5 units. And then shift blank 3 units. So what would I put into the first blank? Shift it blank 5 units. Would y'all go up, down, left, or right? What would y'all put in that blank?
Left.
Left, because see that 5's up there with that exponent. So that's going to go left since it was positive. Good job. And then what are you putting into this blank? And then shift it blank 3 units.
Down.
Down. Good job. All right, then we got to graph it. So remember on the graph, choose the exponential tool again. So your horizontal -5. Vertical -3. Then change the base. Now, it's possible it could have 2 there still since you put a 2 on the last problem, but make sure in the base it does have that 2 there for you, okay? So the first 3 we're dealing with the graphing, okay? Graph number 1, look at the 4 pictures. 2 and 3, you had to describe the moves and then move them on the graph when it opened up the extra box, okay? All right, next we're going to get into those interest type problems, okay?
Can you go back just for a second?
Mm-hmm. So 4 we'll do an interest problem and we'll have to come up with the formula and then how much is
Thank you.
in there after so many years, y'all. And then 5, we're doing Melissa's birthday again. Did y'all say y'all was ready?
Yes.
Okay. So number 4 says, suppose $76,000 invested at 5.5% interest, compounded quarterly, okay, so that's the information they're giving me on this one. So for part A, they want to find the function for the amount that the investment grows. So find the function for the amount the investment grows. All right, so they're going to give us the A of t part of it. And they want us to figure out what's going in here. Now I'm going to write my formula up here again for us. So the amount in the investment at any time t equaled my starting amount, my principal, times 1 plus r divided by n, all raised to the n times t. So remember, r was my interest rate, n was the number of compounds a year, okay? So we start with our principal. Well, that's the 76,000. Then we got 1 plus R. That's my interest rate. Now, what I'm going to do is turn that 1/2 into a decimal. And if you divide 1/2 on the calculator, that equals 0.5. So this is going to be 5.5%. So one of y'all tell me, what would you make this into a decimal as?
0.055.
So 0.0, I think y'all were saying 0.055, which is definitely correct. So y'all move that decimal left twice and added me a 0. All right, y'all, so that's going here, 0.055. How about n, my number of compounds? If it's compounded quarterly, how many times is that a year?
4.
All right, y'all, and then remember, the 4 goes here because the n's in it twice, and then t. Now, we've got the formula, but MathLab likes this part inside the parentheses to be simplified more. So you got to bring down your 76,000. On the calculator, we got to punch in and see what that 1 plus 0.055 divided by 4 equals. So let me quit the graphing. So that'd be 1 plus 0.055 divided by 4. And you want to keep all the decimal digits. So replace that with 1.01375. Okay, so I got that replaced with 1.01375 and then bring down to 4t. This is now what MathLab wants for part A, okay? Although this is right, it's not in the most simplest form for MathLab. Now, B wants to know, find the amount in the account after t equals 0, 4, 5, and 10 years. So we all just put t equals 0 here for the first one. Get that answer. Then I'll do t equals 4. Get that answer. T equals 5. And t equals 10. Well, one of these should be very easy. That should be that t equals 0. If you started with $76,000 and no time has passed, then I'm pretty sure you should still have $76,000. But y'all, let me show you how you can get all 4 amounts pretty quick. And these were rounding to the nearest dollar, so we won't have no decimal places. So y'all, what I do on this number 4 is I'm going to graph it. So I'm going to go to y equals, clear that out. And I had 76,000 parentheses 1.01375 close parentheses. My exponent would be 4 times x. Although it's really a t in the graphs, you got to use x's for all the variables, okay? Now, I don't even want to look at the graph. I'm going to the table. So I'm going to hit second graph. And let me go back up to first one was t equals 0. And y'all look at that. $76,000. Because if no time has passed, we ain't made no money yet. Now I can arrow down to 4. Because see, these y values, if you look at the y values, they're already rounded to the nearest dollar. So at 4, I get 94,560. Now, if you wanted to see the decimals, you could click onto the actual y value and see if you'd have done that on the calculator, you'd have had a 0.0009. So that didn't round up. It just stayed 94,560, okay? All right, next was 5 years. That's 99,869. Then y'all finally at 10 years, let me arrow down. There's 10 years. That is 131,235. Now, I'm not going to lie. You could have punched them in each one individually. So I'll show you what I'd have done if it was a t equals 4. I'd have put my 76,000. Then I'd have put in my 1.01. 375, close parentheses. And then my exponent would have been 4 times 4, since my t would have been 4 on this one. So at 4 years, I got 94,560. So you can get the same amounts punching them in individually. But if you don't want to have to worry about rounding them off and stuff, you can go to the graph and look at the table, okay? All right, now number 5, we're using that same formula. So this is on Melissa's 6th birthday. She gets a $2,000 CD that earns 4%. Interest compounded semi-annually. What they want to know, how much money available on her 10th birthday. Okay, so we're just going to use our formula and plug everything in it. So remember, here's my formula. A of t equals P times 1 plus R divided by N, all raised to the N times T. So, first of all, we need to figure out how many years have passed. So it's her 6th birthday and her 10th birthday. That means that our T is going to equal 4 years for this one, okay? So we're finding A of 4. So remember, we start, P will be the 2,000, parentheses, 1 plus, all right, y'all, 4%, let's see. Decimal form for 4%, what do we got?
0.04.
So that'll be 0.04. So I'm going to put that on top. How about N, which is semi-annually? How many times a year is a semi-annually?
Is it 2?
It's 2. Good job. All right, then that'll be 2 times my t, which was 4. Now this one, They want me to round to the nearest cents. So I'm just going to punch this on the calculator. You got to round it 2 decimal places for cents, okay? So look at the 3rd decimal place to determine if you're going to round it up or down. So we got 2,000, parentheses, 1 plus 0.04 divided by our 2, close parentheses, and then our exponent was 2 times 4. All right, y'all, so we know it's going to be more than 2,000. So look at that. We got $2,343. And look at that. The 1 is in the 2nd place, but it's got an 8 behind it. So I'm going to make that a 32. Okay. So 2343.32. And you also, that's a trick on those. Plugging them into your formula and see what you get. All right, so now they start having me find the logarithm. So y'all, I'm going to find a log base 10 of 0.1. Now remember, you can use the log on front of the calculator. Although it don't show a 10 on it, the log on front is a base 10 logarithm. So y'all, if y'all punch in me a log of 0.1, what do I get?
-1.
-1. So decimals like this or fractions will give us negative exponents, okay? All right, y'all, moving on. I got more for y'all to find logs of.
Can you bring the paper back one more? I missed the couple words.
Okay. Is that enough?
Yes, yes.
Okay. So let's see. So yeah, there's about 4 in a row where it's just nothing but finding logs for us.
I got it.
Okay. All right, y'all, number 7. Same thing, find a log. They're giving me log base 4 of 4 to the 2nd power. Now remember, on that one, I would go to math and arrow down the log base and use that one on this, because you can put in the base 4 on it and then put in the 4 squared. But y'all, what's been the answer? Every time I have a base of a logarithm that matches the base of the result raised to an exponent, what's the answer supposed to be? All right, y'all, so let me
You gotta move it to the front.
say again. Oh, you're doing too much. We just want to evaluate this thing. So just go to your calculator. Okay, so on the calculator, hit math, arrow down to log base, hit enter on that, put in your 4 for your base, and then arrow right and put in 4 squared. So now it looks just like my problem, so I'm going to hit enter, and y'all look at that. The answer is always the exponent, okay? If if the base of the log matches the base of the result raised to an exponent, that answer is always going to be the exponent, okay? All right, y'all try this one. Find the log. It is log base 81 of 3. And this one tells me to type it in as a fraction. So since it says type a fraction under the answer blank, I'm going to assume it's going to be a fraction. So do y'all want to punch in log 81 and 3 and tell me what you get?
Is it 1/4?
1/4. So punching the log, it probably gave you 0.25, and then you just hit math and enter twice and turn that into a fraction. All right, number 9, find the log. Log base 9 of a 1. There's only one exponent that can turn any number into a 1. Because remember, I'm finding exponents that I would raise this 9 to make that a 1. So y'all, what exponent is that?
0.
0. Good job. So I don't care what your base is. If that results a 1, you better put a 0 there, okay? All right, 10 wants me to convert to logarithmic equation. They're giving me 10 squared equals 100. So this is the one where I had to rewrite it using logs. So I would write my log. The base of the log is the same thing as the base of the exponential. So this is going to be a base 10. The result goes next, which is the 100. And that'll equal the exponent of a 2. Okay, so remember, the bases are the same. The base of the exponential is the same as the base of the log. On the log, you then write the result, because the log of base 10 of 100 is an exponent of 2. Okay? All right, so there's 2 doing this. So this one's also convert to a log equation. So y'all, on this one, y'all got e squared equals m. So bring down your log. So what is the base of this logarithm going to be?
E.
All righty. What's that result going to be?
N.
And that's going to equal the exponent of a
2.
2. There you go. All right, so 2 that we had to convert exponential into logs. Now I'm going to convert logs into exponential. So these will say convert to exponential. Now we'll say on this one, MathLab would also take this answer. Since that's a log base E, remember I could use the ln of m equals 2. But it don't require you to do that. So if you just want to leave it a log base E, you can do that, okay? All right, y'all, here we go. We got a log base 6. Whoops. Yeah. Log base 6 of 36 equals 2. So we're going the other way now. So the base is a 6. Exponent would be my 2. And that's going to equal a result of 36. All right, y'all. So here's another one I'm going to let y'all play with. So convert to exponential. And see, this was the stuff we had to know because of those equations that we did in 9-6, okay? All right, y'all. So I'm gonna give y'all a trickier one. Log base A of a capital M equals a negative Y. So the first thing I need is my base, y'all. Remember, the base is the same as the base log, so that's going to be the A. Exponent,
-1
and that's going to equal
to M.
the M, okay? Now, the only thing you got to watch out on this is use capital letters when they use capital letters, okay? All right, 14 says use a calculator. To find the natural log. Remember, natural logs, that's the LN stuff, okay? So they're giving us LN 326.1. Now, this, you're going to round out 4 decimal places. We can pull that right on a calculator, right? So go to calculator. Right on front is the LN button by the 4. So hit LN and put in 326.1 and hit enter. All right, y'all. So let's see, 4 decimal places. So that'll be a 5.7872. And I'm going to keep it a 2 because it's got a 0 after it. So 5.7872. So on that one, you got to round it 4 decimal places like they want, okay? All right, 15. That one says find the log using change of base. Well, what that means, that's old terminology. What we want to use on this is our log base. Okay, so we're going to go to math and go down to log base and do this one. And this one is a log base 4 of 17. We're going to round this one out 4 decimal places. So do y'all want to try that one? Anybody want to try it? All right, y'all, here we go. Going to my calculator.
0437.
Oh, what did you just say?
2.0437.
I think you're right. So let me push that in real quick. So log base. So go to log base. That was what, a 4 and a 17. And that's perfect, right? Because that 7 had a 3 after it. So 2.0437. Good job. All right, y'all. So next, what we got coming up, were when we were using the properties, writing them as sums and products and differences and all that fun stuff, okay? So these will start at 16. So the 16 says express as a sum. So if we're going to express them as a sum, they're giving us a product. They're giving me a log 11 of 11 times 121. Now, they don't want us to evaluate this. They just want to express it as a sum of the logarithms. So we take the log base 11 of 11. And then a sum means they're going to be added. And then it's the log base 11 of 121. All right, they're now written as a sum. That's as far as we got to go. 17, expressed as a product. So this one, they're giving us a log base m of t to the 7th. Now, MATLAB likes putting parentheses around it, but we don't need parentheses here. But when they say express as a product, there's only one thing we can do to this. And remember, let's take that exponent and bring it down to the front, so that this becomes a 7 times a log base m of t. And once again, y'all, be careful with the capital letters on that, okay? So little t and a capital M was how they gave it to me. But when they express as a product, that's all that means on the one that says express as a product. Bring the exponent down, okay? 18 says rewrite as sums or differences. They're giving me a ln of parentheses x to the 3rd, y to the 3rd, and a z. Well, these are all being multiplied just like this was being multiplied up here. So when stuff's being multiplied, it'll actually be rewritten as a sum. So that's why they got the or here, either or, okay? So products get written as a sum. So distribute the ln to the x 3rd plus distribute the ln to the y 3rd plus distribute the ln to the z. Now I need to know, can I go any further on this? So on this one, y'all better be thinking about that product rule we did up here. Because I see a couple exponents here. And remember, these exponents have to be brought down to the front so that you get a 3 ln x plus a 3 ln y plus my ln of z. Now you also remember, bring those exponents down. All right, same thing here. Express is sums or differences. Now this one says express as sums and differences. So since you're saying and, you're going to have both on this one, okay? So we got a log base b. Now we got big parentheses. I got a P4 Q7 over M5 B8. Now here's the thing about the fractions. All the factors on the top are added. All the factors from the bottom get subtracted. And we distribute that log b to all 4, okay? So we'll have a log b of a P4 plus a log b of a Q7. So the top two were positive, okay? Now everything else on the bottom gets subtracted. Log B of M5 minus the log B of B to the 8th. Now, I will say this. 3 of these, I'm bringing the exponents down. But this one, I got a log base that matches a base raised to an exponent. So this whole thing is only going to equal the exponent. Okay, if that base matches that base of the result raised to an exponent, that's going to equal 8 only. See, nothing else has a matching base. So this one bring down to 4 log B of P plus the 7 log B of Q minus 5 log B of M minus 8. So you are going to have one of these that converts into the exponent just like I did, okay? All right, y'all, the next one says simplify the expression. They're giving me a ln of x squared plus 7x plus 12 minus a ln x plus 4. So the first thing we got to do is rewrite it as a single log. So since these are being subtracted, remember, stuff that got subtracted ends up like a fraction. So I'm going to have my ln. My fraction on top is the positive factor. So the x squared plus 7x plus 12 goes to the top. And then this factor being subtracted goes to the bottom. So it's like you're pulling that ln out and then rewriting them where they go. Now, this one will simplify further. So what we need to do is factor the top of this. So I got an x and an x. All right, y'all, these are going to be positive on mine because the last one's positive. They're both positive like the middle. So all we need are factors of 12 that add to get 7. So here's
3
your
and 4.
so 3 and 4. Yeah, because you'd had 1 and 12, 2 and 6, 3 and 4. So there you go. But now look what happens. Those x plus 4's cancel out. So my final answer is ln. Now you got to keep this one in the parentheses because there's 2 parts. And put your ln x plus 3. But y'all, that one's a multiple choice answer. So you'll see the one that you need to have. They'll have the parentheses there for you, okay? Now, they'll have this answer also. But listen, that answer, although it's correct, it's not all the way simplified, okay? You got to remove them common factors to simplify something all the way. All right, y'all, 21. Oh, we start solving for the x's. So mine is 5 to the 9x equals 25. So first I would try to do on the exponential, I try to rewrite this as the same base raised to an exponent. Well, I can rewrite 25 using 5s. So y'all, I'm going to bring down that 5 to the 9x. That'll equal 5. Well, how many times do I multiply 5 to get to 25? That'd be 2. So remember, at this point, my bases matched. If the bases match, that means we got to set the exponents equal to each other. So this 9x equals 2. Now, solving for the x, we're going to divide by 9. So that cancels, and I get x equals 2/9. So if you put the 2/9 here, the 9's cancel, and you're left with 5 squared, which is 25. So these have to work out when you put them answers in, okay? And y'all, I'm going to tell y'all the truth. They're going to have a choice that says the solution is not a real number. On these equations, 21, 22, 23, 24, and 25, if you choose the solution is not a real number, you're going to miss it. Do not click that. All of these will have a solution, okay? All right, y'all, so let me get my paper ready. All right, so that was the 5 to the 9x, right? So next is number 22. Solve. Now, I'll tell you a trick on these. Let me show you something on these. This one I just solved, it says simplify your answer, type an integer or fraction. Okay, so that means I knew I'm not getting a decimal on that because they want an integer or fraction. This next one, look here, it says round 4 decimal places. So that means I'm probably going to get some kind of decimal, okay? So y'all, here we go. We got 3 to the x equals 10. So this exponential, I cannot rewrite 10 using 3's because 3's go 3, and then 3 times 3 is 9. 9 times 3 is 27. So I'm not getting a base 3 on this side, okay? So when I couldn't rewrite them using the same base, I took logs of both sides. So I did a log of 3 to the x equals a log of 10. Now, since I did that, I can now bring the exponent down and make this a x times log 3 equals log 10. And y'all, final step, divide both sides by log 3. That's going to equal log 10 divided by log 3. So those will cancel. So we're approximating it. Now remember, in the calculator, I want them in parentheses. Unless you use the alpha y equals and make it look like a fraction, okay? But you could do parentheses log 10, close parentheses, divided by parentheses log 3, close parentheses. I like to use that alpha y. So the green button and the y equals and enter. That way I can actually put my log 10 on top. So log, put in my 10. And then I can arrow down to the bottom and put in my log 3. All right, y'all. So remember, 4 decimal places. That's going to give me a 2.09. And it looks like that's going to stay a 5.9 because of that 0 following that last 9, okay? Now, y'all, let me show you. You could have did this. Parentheses, log 10, close parentheses, divided by. Whoops, let me go back and close my parentheses. And then divided by parentheses, log 3, and then close both of those parentheses. You have 2 parentheses in a row on the right side because they open another one when the log comes up, okay? But when I hit enter, same answer. All right, so remember, 21 you can actually rewrite as the same base. 22 you got to take logs. 23, solve for x. Log base 3 of 2x minus 7 ooh, excuse me, equals 1. So since this is a single log equal to a number, I'm going to rewrite it as exponential. So my base is 3. My exponent is the 1. That's going to equal the 2x minus 7. So this is why you had to learn that stuff earlier when you had to rewrite as exponential and rewrite as logarithm, okay? So that's really just a 3 because 3 to the first is 3. So to solve this, I'm going to add 7. So that'll give me a 10 equal to my 2x. And then, y'all, I'm going to divide by 2. So those cancel, and I get my x. And then 10 divided by 2 gives me 5. Well, 2 times 5 is 10. 10 minus 7 is 3. So the log base 3 of 3 equals 1 is true. All right, y'all, same thing. 24 solved. Log base b of b plus 14 minus log base b. Whoops, those are 4s, y'all. My bad. Log base 4 here and log base 4 here of a b plus 6 equals log base 4 of a b. So log base 4 of b plus 14 minus log base 4 of b plus 6 equals log base 4 of b. So I need to combine these into a single log first. So since they're subtracted, it'll look like a quotient. So bring out your log base 4. Positive factor, b plus 14 goes to the top. Factor that's being subtracted goes to the bottom. So that's my b plus 6. That's going to equal a log base 4 of a b. So if you notice on this one, the log bases match on each side. So if the log base 4 matches the log base 4, that means this result equals that result. So b plus 14 over b plus 6 equals b. Hey, y'all, so I'm going to put a 1 under this just to make the b look like a fraction. Because remember, to solve this, I'm going to cross multiply. That's why we gave you all that support on cross multiplying, okay? So this top b plus 14 multiplies by 1. So 1 times b is b plus 1 times 14 is 14. This bottom, both of those, multiply by that top. So b times b is b squared plus 6 times b is a positive 6b. All right, so let me show you what we got going on. This has a b squared in it, so that makes this quadratic. So I need everything on one side equal to a 0 here. So I'm going to subtract b from both sides, and I'm going to subtract 14 from both sides. So b minus b is 0. 14 minus 14, 0 on that side. This side I got a b squared. 6 minus 1 gives me 5b, and then my minus 14. So y'all, to solve this, I'm going to factor. So I got a B and a B. That last sign's negative, so one's positive, one's negative. So I need factors of 14 that'll give me a 5. So let's see, we got 14
2 and 7.
and 2 and 7. So that's all I need. So remember, 7's bigger, it's going to be positive like the middle, and a 2's negative. All right, y'all, we're factored. Now, let's set both of them equal to 0 and solve these variables. So I get a -7 on the first one, so I get B equals -7. I get a +2 to both sides, so that I get a B equals 2. What would my final answer be?
Is it a 2?
It is a 2. Because remember, if I put that -7 in here for these B's, I can't take the log of a negative number, so you gotta cancel the negative answers on the log equations, okay? So y'all, the only answer is the B equals 2. Now this one, you won't put the B equals in it. It just says the solutions are. So they're going to say the solutions are. All you're putting in is your 2, okay? All right, so I'll give y'all a second to write that, and then we got number 25 coming up. All right, y'all good? All right. All right, y'all, so this will be the last one on here, number 25. And of course, it is a solve for x. Another log equation. Log base 2 of x plus 3 plus log base 2 x minus 3, all that equals 4. So we got to combine logs on the left side. These are being added, so we're going to write this as a product. So log base 2 x plus 3 times the x minus 3. All of that's going to equal a 4. Now, y'all, I actually go one more step on this. And I'm actually going to multiply this out. Now, remember, these are conjugate pairs. Okay, so x plus 3 times x minus 3. We can shortcut that. We can do x times x and get an x squared. And then 3 times -3 is a -9. Remember, you don't have to FOIL the whole thing out because the 3x and the -3x are going to cancel anyway. So now I got a log base 2 of an x squared minus 9. That's going to equal 4. So notice this one don't have logs on both sides. So since we got a single log equal to a number, we need to do like we did on number 23 and rewrite it as exponential. So my base is a 2. Exponent is a 4. And that's going to equal that result of an x squared minus 9. All right, so I guess we need to figure out what 2 to the 4th is. What do y'all think 2 to the 4th is going to equal?
16.
All right, so I got 16 equals x squared minus 9. Y'all, 2 ways to solve this. You can bring the 16 over here and factor it as different squares like you got here. This x squared minus 9 would factor into a +3 minus 3. You can bring the number over and factor it, or you can add 9 to both sides and do square roots. I like square roots, so I'm going to get the x squared by itself by adding 9. So that's going to give you 25 equals x squared. Next, we're taking square roots. Are we worried about the negative square root of this one? Because remember, every time I did square roots, I had a plus or minus. But y'all, we're doing a logarithm equation. We can't keep the negative numbers anyway. So, only answer I'm worried about out of the square root of 25 is a 5. Okay? So remember, not worried about the negative 5 since we can't take logs of negative numbers. So my only answer would be the 5, and this one will say the solution is x equals blank. So you don't even have to put the x on this, just come in and put your 5, okay? Alrighty, so let's see. That looks like 25, y'all. So that is our test 4. So that means we're going to come in. Let me see, what's tonight? Tonight's Thursday. So we're going to come in Tuesday. Oh, I'm all mixed up. Today's Wednesday, right? So we're going to come in Monday and do our final exam review, okay? And the final exam will open on May the 8th on a Wednesday. And I don't remember what I got for the due date. I might have the 10th, but I think it's the 10th or the 12th, either one, okay? I'll check and see for sure. Because what I was going to do, we don't have to have grades turned in till the 14th, I think it is. So I might keep the final open through Sunday night in case any of y'all work and you can't do it on a Wednesday, Thursday, or Friday, okay? But let me make for sure we're able to do that. And if I can, I'm going to keep it open till that Sunday.